and welcome to EasyMath channel. This week we will focus on understanding how to plot a box and whisker plot. And it's super simple, it's super easy. And the concept that we'll be using for this video kind of also focuses on some of the concept that we looked in the previous video where I discussed about median, mode, mean, and range. So if you have not seen that video, I would recommend going back to my last video, which was last week on mean, median, range, and then come back to this video because this video will be using some of the concept from the last video. Anyway, so in this video, before I jump into how to plot a box and whisker, let's look at some of the main highlights of this plot, and then we'll look at a couple examples, and at the end I will also talk about how can we use box and whisker to identify outliers. Cool. So as you can see on this first thing, the box and whisker plot, we also call it sometimes as just box plot. And within box and whisker plot, it helps us identify 5 different key points or 5 kind of summary for a given data set. So first it's the minimum, which is also known as lower extreme. Second is the first quartile or Q1, also known as lower quartile. Now a quartile is a general definition would be quartile as in like 4. So usually you can divide the entire data set in 4 different area. So lower quartile, middle quartile, and upper quartile. So Q1, Q2, or Q3. So it's first quartile Q1, then second quartile, which is Q2, also known as median. Third quartile Q3, also known as upper quartile, and then the maximum, which is also known as upper extreme. So in short, it's nothing but it kinds of the box and whisker plot kind of helps us visually look at how the data is distributed, through the quartiles, since we have a lot of quartile in this data. And we'll also see why this plot is called a box and whisker. Okay, so let's look at an example and let's plot a box and whisker. So let's say we have the following data set, which is nothing but heights recorded in inches, and it's arranged in order. In case if the given data set is not arranged in order, the first step would always be to arrange starting from the lowest data to the highest data. Cool. So first step always when it comes to plotting a box and whisker is to arrange the data. Second is, now if after arranging the data, the first point is always the lowest one, is called the lower extreme or the minimum. The end point is called the upper extreme or the maximum. And the median will be the number in the center. So let's see how many data points do we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this 3, 4, 5, 6. So this is the number in the middle. So we have 6 number on the left and 6 number on the right. So this becomes our median. If in case of odd numbers we had even numbers, median would be average of the middle too. So this is our median. So we know 3 points at least. So we know our minimum, we know our median, and we know our maximum. The next step would be to calculate the lower quartile or Q1. Now the lower quartile would be, so we have this 6 number to the left of the median. So the middle or the median of that, the middle of this data set is our lower quartile, and the middle of this, let me just change my color, it's easier to look at. So okay, so the middle of this data set would be our lower quartile, and the middle of this data set would be our upper quartile. Just make a note that I'm not taking 36 in while calculating lower and upper quartile. I'm excluding 36, which is the median. So our lower quartile Q1, or the first quartile, is nothing but the middle number. So as you can see, this is an even data set, so median we would be 26 plus 30 divided by 2, which is 28. And the upper quartile, which is Q3, is nothing but the average of this two, which is 38 plus 40 divided by 2, so that's 39. Okay, so that's how we get all the 5 points. We get our lower, the minimum, our median, the upper extreme, and then we calculate Q1, and then we calculate Q3. So okay, so now let's plot, and let me pick another color, and now let's plot our box and whisker plot. So I will just write down again, minimum is 21, maximum or upper extreme is 52, median is 36, quartile 1 is 28, and quartile 3 is 39. Okay, so now let's plot our box plot or box and whisker plot. So let me draw a scale first, and let's say it starts from 20, 25, 30, 35, 40, 45, 50, 55. Cool. So minimum is 21, which is somewhere here. Our maximum is 52, which is somewhere here. Median is 36, which is close to here. And then Q1 is 28, so which is somewhere here. So Q1 is here, which is 28. Q3 is 39, which is close to 40, which is, let's say, close to here. And then let me make a box first. And then median is 36, which is close to here. And then we'll join this box with a straight line that goes from the lower extreme or minimum to the higher extreme, which is 52. We can either draw a dot at the end or a straight line, doesn't matter. So this is how we plot, this is how we make a box plot. The reason why it's called a box and whisker is you can say that we have a box, and then we have this whisker looking thing, which is a straight line that goes from lower to or lower to the upper extreme. Okay, so this is called Q1, this is called median, this point is called Q3, this is called the maximum or upper extreme, and this is our minimum. So Q1, this is 28, this is 36, this is 39, this is 52, and this is 21. Okay, so for for this data set, this is how we plot, or this is how we make a box and a whisker plot. If we were just given box and whisker plot, we wouldn't know the entire data set, but will just by looking at it, we'll be able to say what's the minimum, what's the quartile, Q1, what's the Q3, what's the median, and what's the maximum, which is an important property uh, to understand any distribution for a given data set. Cool. Let's look at another example where we are given the plot, and we'll have to figure out the range and the median for a given box and whisker plot. And I apologize for my terrible drawing here. Okay, so before we answer this question, let's look at all the quartiles or all the information here. So this is our minimum point, which is 50. Minimum is 50. This is our maximum, which is 90. This is our Q1, which is 60. This is our Q3, which is 80. And this is our median, which is kind of in the middle of 70 and 80. So let's say 75. So if you remember, range is nothing but the difference between the maximum and the minimum point. And I've also discussed how to calculate range in my last video as well. But in short, range is nothing but it's the maximum value minus the minimum. So this is 90 minus 50, 40, and the median is nothing but this line in the middle of this box. So in this case, our median is nothing but 75. So as you can see, it's so simple. When given a box plot, we can know what's the quartile 1, what's the median, what's the quartile 3, and what's minimum and maximum. So this is how you calculate median and a range for a given box plot. So lastly, let's look at outliers. Now there are other ways to figure out what an outlier is, and it's very important concept when it comes to understanding outliers, because we would want to not consider or do not want to take outliers in our calculation because it can skew our analysis. So for example, if I want to figure out, say, how much on average people in America makes, I would want to take out, the top 1%. So like Bill Gates or Mark Zuckerberg or Warren Buffett, because they make billions and billions and billions. And if I use those data points in my calculation, I might get a very skewed data, and which will never be true. On average, whatever income will I get using those data points. So it's always important to figure out what the outliers is, or what the outliers are, and then take them out of the analysis. So one of the way to calculate outliers in statistics, I'm sorry about that. So one of the way in statistics, or one of the way using box plot to figure out outliers, is first to calculate interquartile range. Interquartile range is nothing but the upper extreme, the upper quartile, which is Q3, minus the lower quartile, which is Q1, and any number that falls below this, which is quartile 1 minus 1.5 times the interquartile range, or any number that falls above Q3, which is upper quartile, plus 1.5 times interquartile range can be considered as outliers, which is, I mean, using a box plot, this becomes so easy to figure out what the outliers are. So what are the lower outliers and the upper outliers? Um, and this is usually a method follows in statistics to figure out outliers for further analysis. So with that, we conclude this video about box and whisker plot, and I hope this was useful, and I hope I was able to explain the concept of box and whisker as easy as possible. If you like this video, please subscribe to my channel EasyMath, and please leave your comments below. Thank you.